Alright, so now let's look at some examples discussing the concavity of each function. In other words, find all the intervals where the function is concave up or concave down, and then finding all points of inflection. As always, if there are none, state this. So start out with a nice easy polynomial. So f of x equals x cubed minus 6x squared plus 1. So just like before with finding extrema, first thing you want to do is find your domain, because that's always going to be your starting point for intervals. In this case, our domain, negative infinity to infinity, since it's a polynomial, right? So for concavity, you can think of this as doing the same exact process that we did for the first derivative test. The only difference is we're doing it on the second derivative now. So to get there, you've got to find the second derivative. So f prime of x, you have to go through the first derivative first. So that's 3x squared minus 12x. And so then f double prime of x is going to be 6x minus 12. All right. So finding all points of inflection, or possible points of inflection, what we have to do is we have to find all the x values where f double prime now is equal to 0 or is undefined. So the same exact method of thinking that we used before. So f double prime of x undefined, f double prime of x equal to 0. In this case, well, f double prime's never going to be undefined, right? Because it's a polynomial. And then from here, so f double prime equal to 0 means 6x minus 12 equals 0. 6x equals 12, x equals 2. So the only possible point of inflection in this case is x equals 2. So now we're going to check the second derivative the same way we checked our critical values in the first derivative for intervals of increasing, decreasing. Now we're going to check the sign of the second derivative about our possible point of inflection, x equaling 2, to get our concavity. So the exact same method of thinking. Draw out an interval. So start with your domain, negative infinity to infinity. And then in this case, x equaling 2 is our possible point of inflection. So we have the intervals of negative infinity to negative 2, positive 2, and positive 2 to infinity. So pick a test value in each of those intervals. So let's say 0 and 3. Just like before with finding extrema, it doesn't matter what value you pick as long as it's in the interval and in the domain. So same idea. So test points in negative infinity to 2, we picked 0. 2 to infinity, we picked 3. So now we're plugging into the second derivative, so f double prime of x. We know in this case is 6x minus 12. So f double prime of 0, 6 times 0 minus 12, which if we think about that as factored form, so that's 6 times x minus 2, makes it a little bit easier for this part, because then we're just looking at products instead of sums and differences. So 6 times x minus 2. So this is 6 times 0 minus 2. So 6 is going to be positive. 0 minus 2 is negative. So that means that f double prime of 0 is less than 0. Which then means we can say that f is concave down. On the interval 0 to negative infinity to 2. Similarly, f double prime of 3, 6 times 3 minus 2. So 6 is still positive, 3 minus 2 is positive. So this is greater than 0. So f is concave up on due to infinity. And then, just like before, write it out in interval notation. In this case, there's only 2 intervals, so I'm just going to box in what I've already wrote. And then, so now looking at the concavity change, so our concavity in this case is changing. It's going from concave down to concave up at x equaling 2. So then f of x is going to have a point of inflection at 2f of 2, which then is equal to 2 comma negative 15. Remember, how do we get that negative 15? You're finding f of 2, right? So that in this case is going to be 2 to the third power minus 6 times 2 to the second power plus 1. And that's how we got that negative 15. Another thing to remember, x is equaling 2 is in our domain of f of x. So concavity can change at a vertical asymptote, but there won't be a point of inflection there. So in this case, because x equaling 2 is in our domain, that's why it's a point of inflection. All right, let's look at the second one. So f of x equals x over x plus 1, a nice rational function. So same idea, step 1, find your domain. In this case, our domain is going to equal to negative infinity to negative 1, union negative 1 to infinity. Remember, you get that by setting the denominator equal to 0. Use the quotient rule to find f prime of x. So f prime of x is 1 over x plus 1 squared. So then you can rewrite that and use the chain rule. So this is x plus 1 to the negative second power. So then that makes it easier to find the second derivative. You don't need to use the quotient rule again. F double prime of x then is negative 2 times x plus 1 to the negative third power times 1, just using the chain rule, right? Which then is negative 2 over x plus 1 cubed. All right, so now we want to find all values where f double prime is undefined and all values where f double prime of x equals 0. So f double prime of x, let's take the equals 0 first this time. So equals 0, that means we're just setting the numerator equal to 0, so negative 2 equals 0. So that doesn't make sense. That tells us that f double prime of x is never going to equal to 0. So then we have to deal with the critical values, or sorry, the values where it's undefined. So x plus 1 to the third power equals 0 is going to be somewhere that it's undefined. So then that's x plus 1 equals 0, so x equals negative 1. But remember, this is not in the domain, so it's not a possible point of inflection. There cannot be a point of inflection at x equaling negative 1. But remember, concavity can change about a vertical asymptote. In this case, x equaling negative 1 is a vertical asymptote. So we still have to just look at the concavity and decide if the function is concave up or concave down. So we still have to do the test on our domain. So in this case, our only intervals we're going to have are the domain. So negative infinity to negative 1, negative 1 to infinity. So if we look at the interval negative infinity to negative 1, a good test point there, let's say negative 2, x equals negative 2, and then from negative 1 to infinity, nice easy number, pick 0. So f double prime of x we know is negative 2 over x plus 1 to the third power. So f double prime of negative 2 is going to equal negative 2 over negative 2 plus 1 to the third power. Negative 2 we know is a negative number. negative 2 plus 1 is negative, so that to the third power is going to be negative. So we have negative divided by negative, which is positive. So that implies concave up. F double prime of 0. So that's negative 2 over 0 plus 1 to the third power. So that's negative over positive, since 0 plus 1 is positive. And so that's going to be something overall. The second derivative is less than 0. So concave down. So then our intervals of concavity, so F is concave up on the interval negative infinity to negative 1, and it's concave down on negative 1 to infinity. But remember, x equals negative 1, even though it's changing concavity there, x equaling negative 1 is not in the domain of the function. So there is no point of inflection. There's no point of any kind going on at x equaling negative 1. So f has no points of inflection.